So for a year or so now, I've been worrying about whether we're missing some mathematics about understanding living systems, and I've been trying to nibble away at what that mathematics might be. I still don't know, but I've been concerned about our understanding of the role of computation. We have a computation-centric view of artificial life. Is computation enough, or is there something more? And what sort of computation? Is Turing computation all there is? So there are a number of questions. One of the questions is, do physical systems with non-exotic physics do more than Turing computation? If so, maybe our attempts to build artificial life from current digital computers are ultimately doomed. So we need to understand that better and know one way or another. So I think that's an open question we need to study. But then, even if we have, suppose Turing computation is enough, or it's not, doesn't matter either way, maybe our organization of computation doesn't match the computation that happens in living systems, because we've been thinking in terms of a Turing model where essentially you have uniprocessors following a set of instructions, and computer science has been built around the notion of what's the asymptotic complexity of such computations, computing functions, or computing memberships of sets. So one can ask very different fundamental questions. One might get very different mathematics of computation. Instead of asking how long does it take to compute a function as in terms of the input size, one could ask a different set of fundamental questions. One such fundamental question might be, under what sort of conditions could all the components of a computer, gates say, be maximally utilized during the computation? And that would get a very different sort of complexity classes of problems. Or one could ask, what sort of parallelism could there be inherent in a problem where instead of having each individual element follow instructions, they're essentially stimulus-response entities that are acting in parallel, much like in all biological systems or chemical systems where all the atoms and molecules operate in parallel. Or one could ask another fundamental question, even under a Turing model. What's the rate of divergence of a computation if you have a one-bit error in the specification? And if you followed that, maybe you'd end up with systems which were much more robust in their coding, such as biological systems. So I think there's lots of different things we could ask about computation, different from what we've been asking the last 50 years, and perhaps that would have impact on what we do and see in artificial life.